everyone and welcome to a new discussion. It is in continuation of our earlier discussion in up to part 13. We have been discussing about groundwater exploration, and in the previous one we have also discussed the drilling methods and what are the options and in which condition which drilling is more suitable and so on. And during that time also I mentioned that once a drill hole is there and if a very large quantity of water is required with some special quality constraints, and for say for industry or some large usage, then we also resort for the well logging or recording whatever the lithology which is available. So, one way of collecting information about subsurface conditions is going through the lithologs or rock pieces which are cutting through these drilling process, but that will give you only some information, not to a very large extent or in detail information. But if you want to know the other characteristics of rocks like their resistivity and density and other things, then we have to resort to subsurface geophysical techniques through well logging. So, but in this discussion first we are going to very briefly discuss hydrogeological well logging and then we will discuss the geophysical well logging. So, first hydrogeological well logging, in which whatever the observations are made during drilling will constitute a log. Log means a record of whatever the material which is coming during time of drilling. And when we were discussing drilling, we discussed that everything whatever is possible is recorded, what is the time and how drilling is going, whether it is going fast or slow, the sound and water is coming, mud, all kinds of information, and that is stored in a log, or we also sometimes in loose language we say litholog, but when we say litholog it is mainly about rocks. But if we also record the time and other things, then it in general we can say a log. So, there are as you know, for the surface geophysical methods we can also do here, but before that we will be say where this electric logging has been done in the case of lithology for basically talking about the surface, then we can describe more accurately the formation boundaries and can read more precisely. And we expect that we will be having a better knowledge for subsurface also. If drilling is done by this down the hole hammer or percussion rig or percussion method, then we get the some preliminary hydrologic analysis of the data is possible, because the whatever the data or water which is coming, if it is analyzed geochemically and otherwise, then we get about information about salinity, pH and other things also. So, it depends on what kind of drilling method. So, as mentioned that whatever at that stage, whatever is possible to record, everything should be recorded. Now, we will see one example of hydrogeologic log of a granitic well, which is shown here. The three, four informations are shown. One log is coming, this litholog is coming through our recordings during the drilling and the pieces which we are coming. What we see here that at the top we are having some weathered granite, as you can see here, the top part, which is a very common characteristics of a granitic terrain. That top part would be a weathered granite. Also at what depth the water was struck in this area, that is also shown, you can call as a water level. And then you get a further fractured granite in this portion, and then again you get a massive granite, then again you get a fractured granite and then get massive granite. So, what would happen that this fractured granite becomes a confined aquifer conditions, because top of which overlaying and underlying rocks are massive granites. But in this example, the thickness of this fractured granite or this confined aquifer is only 6 meter, but does not matter, this can provide a good quantity of water also in confined aquifer condition, that is what a most preferred one. But here in the first log is having, this is completely lithological log. So, it is having lithological information, then you are having drill time, minutes per meter. What is the speed of drill? So, if you observe here that when we get this horizon, which is a fractured granite, the drilling time is very less, and that is a good indication that some new horizon has been encountered by the drill machine or the bit. So, that is why it is taking less time, whereas in the massive granite it is taking more time, as you can see here 8 minutes or something per meter. And when we go deeper, it is further taking more time. That means this massive granite and this massive granite is having also some difference in terms of compactness, less weathered, less fractured kind of thing. So, in this litholog what you are seeing, weather granite, then massive granite, fracture granite and so on. And the drilling machine, the behavior of drilling machine will also depend accordingly, as shown through this drill time log. Then another recording at the time of your boring or drilling is the depth to water level, at what time the water was encountered. So, here the water struck at this stage, and then see here it is the 10 meter, it is the 20 meter. So, initially it was stuck, and then of course, you were getting water for most of the time in this well, maybe in this portion you are not having water, and then suddenly water level reduces here. Now, when we come to this last log, which is having the Q, and the Q is given in LPS, that means liter per second, and that too when you struck this thing. So, the transmissivity is also given here. So, transmissivity is also there, Q is there, and then so it is also varying as we go deeper and deeper in the well. So, the top part we find that this is a ferritic zone, then we get a confined aquifer as discussed earlier, and the T, the transmissivity or this other factors, their values are also obtained during this time. So, for a comprehensive picture of the hydrogeological conditions in the borehole, the lithological drilling time and other hydrogeological or hydrological data can be plotted side by side and for interpretations, and this is how it is done. Most of these logs, different logs are plotted side by side. So, the comparison can be made. If like here I am getting very less drill time, then it has to be something important, that is why it is getting. And in hard rock terrain, like this is the example from granitic terrain, then it becomes further important. And there in other cases there might be even caves and other situation might also be there, but anyway. So, the logs what they are represented in this example is also you can record the pressure conditions if a different kind of drilling where compressors are used, pressure conditions, even if water is used, then again pressure conditions are also recorded, and fracture permeability can be interpreted also, because how much permeability is available during that fractured granite, that can also be recorded. So, lot of information, or I would say maximum information, maximum possible information during drilling is recorded and should be recorded. And then we are basically looking the fracture aquifer in case of granitic terrain seems to be well confined, as you can see here, that overlying and underlying rocks are massive granite here. Now, we come to the next discussion in this session or in this lecture or video, that is the geophysical well logging. So, surface geophysical methods we have discussed, and almost the same way subsurface geophysical methods or geophysical well logging is done. The only difference here between that there you were doing everything on surface and trying to get information from subsurface condition by lowering the instrument in the bore well. In case of surface, you are putting all instrument on the surface, but here you are putting all instruments inside the bore well, and that is why it is called well logging of a bore well. So, geophysical well logging includes the techniques of lowering, sensing devices or sensors in a borehole and recording some important physical parameters or characteristics of the rocks which are present. And then these are interpreted in terms of rocks. Lithology is important from groundwater point of view. Their contained fluids, what kind of fluids are there in this case mainly we are talking about water, and construction features of the well. If some work has already been done to shape the well, then what kind of construction, whether gravel pack has been done or cemented has been done, that information can also be gathered through these lowering sensing devices or these instruments which we lower in the bore well. So, depth wise sequential record, as the instrument goes downward, it keep recording these physical parameters which we will see, and that these physical parameters might be the resistivity as in case of surface geophysical methods. Here we also record temperature, because for many industries the temperature of water is also very important. Generally it is assumed that the groundwater temperature will not change with seasons, but even if it does not change, but the industry might be requiring a certain temperature water. They have this information, then they know what to do with that, whether they have to, if cooling is required, then they have to lower the temperature of that water which will be coming out from the well, or a high temperature is required, then they have to heat up. So, that but initial information about the temperature is very, very helpful. So, all these kind of parameters are recorded which constitute a geophysical well log, and measuring systems which involves our sensors, signal conditioners, and our recording devices. So, their instrument is going, it is recording, and of course, they are all connected with cables. So, on surface you are getting all kinds of information as well as recordings there. So, first we will look at one of the popular methods of geophysical well logging is electric logging. So, in electric logging, for evaluating formation characteristics and boundaries and salinity of interstitial water, the water which is trapped between grains, or whatever the fractures, fine fractures or others. We also measure resistivity, spontaneous or self one also measured, and depth in a mud filled hole. So, whatever again it is possible through electrical logging is done about these bore well, and normally both are recorded together at the same depth scale. So, whatever is being done, it is recorded with depth so that we can plot. Like if I take this example of electrical logging, then this is the simplified circuit of that you are having one instrument here or one electrode here, another one is lowered, and then you keep measuring the current, and that will give you information about the lithology. So, spontaneous potential or SP and single point electrode resistivity logging are shown here. So, the SP curve is generated, but once you get this side by side, what you would see that when SP curve is there, then you get a peak in the SP curve, and then you find that here you are getting a sandstone, and this sandstone is confined or overlain or underlain by shale. So, then it is in that case, in this example, it becomes a confined aquifer conditions, and this is what the target is. So, SP curve will indicate which area might be confined aquifer conditions, and through litholog you can make sure that this is what is happening. And these curves which you also seeing about, or contours of electrical resistivity, which you can see also here, they too are indicating that some major changes in the lithology are being observed here. Further, electrical logs are best interpreted in conjunction with the accurate geological log. So, you may get all kinds of logs, but first you have to have a litholog, geological log, and that is what it is recorded at the time of drilling. So, that becomes in side by side we keep all the time and then try to interpret all this log, electric logs or some other logs which would be coming in future. So, every log which is coming or based on well logging has to be compared with the litholog which we have already obtained. Now, in case of resistivity, typical resistivity log, a well logging method to characterize the rock or sediment in a borehole by measuring its electrical resistivity. The same, almost the concept why it is same, but approach might be different and results of course, because it is going in through a instrument which is being lowered inside a well. So, resistivity is a, as we know, that is a fundamental property which represents how strongly material opposes the flow of electric current. And in the logs which we will obtain through this resistivity surveys or resistivity well logging is measured 4 electric probes eliminating the resistance of the contact leads. So, here in the previous example as we have seen here, the 4 electrodes have been used and that is the example is being shown here. Anyway, so we come to now a typical resistivity log along with lithological log. So, what we are seeing that lithological log is present here. Now, we are having a resistivity log and as the lithology is changing, the curve in resistivity is also changing. So, what we see here, the top part is having shale. So, resistivity here is not much, but as soon as we come in case of dolomite or limestone terrain or calcium carbonate zone, then resistivity is going high here. Then again we encounter the shale. So, again it is going back and then we get a coal which is having very high resistivity and so on we keep getting. So, when we compare with the lithological log along with the resistivity log, good interpretations can be made about the subsurface conditions of the lithology present there. Further, in case of resistivity logs, wherever the water table or water level is there, then that will also influence. If it is saturated rocks may be of the same type, but if one is saturated in the top part, in bottom part it is not saturated, then the resistivity will change immediately. So, that way will also indicate that where this water level has come. Now, in the absence of dissolved ions, the water is a very poor electric conductor and sometimes you do not have at least in the top part in hard rock terrain also. So, thus water itself does not significantly contribute to the conduct electricity in an aqueous solution. So, these are the more detailing about this. Now, the resistivity of pure water at 25 degree centigrade is 18 mega ohms centimeter and its conductivity is about that is C equal to 1 upon R is 0.055 microsiemens per centimeter. So, this is what we know at that 25 degree, but if temperature is changing then we have to look for some interpretations of lower temperature thing or higher temperature either through table or some standard curves to find out what kind of resistivity or conductivity is expected from the water. Now, if water is saline then it is a different scenario, if water is having pollutant it has got the different scenario. So, all those things have to be kept in mind while interpreting such data. Now, as we know that the principles of resistivity logging is the same as in the surface resistivity measurements. It is the same concept why it is same. So, here what we are seeing a characteristics log features in fresh and saline water bearing aquifers and associated lithological types. So, as said in the beginning of this discussion, when we started discussion on typical geophysical well logging or even hydrogeological well logging, I said the first requirement is to put a litholog on the leftmost side. So, here a litholog is there and description of each units of litholog are also shown there. Then drill time is shown here, then spontaneous SP data is also shown, then resistivity is there, then gamma log is there, then neutron log is there and caliper log that is showing the diameter of a well. So, because the casing and other things have not been done, if it is done, then many of these information cannot be obtained. So, before casing or before lowering a pipe or perforated pipe or a screen, all this is done. So, what in this case the caliper log is showing that the diameter of a well is not uniform throughout its length. And why it is not uniform? Because of different lithologies which is being encountered with depth. So, you see then when you are having shale, it is different. When you are having porous sandstone, you are having different shale. So, if I plot this caliper along with the litholog, you can interpret that where things are going. So, if like here, see this is porous. So, if we bring here, that is a porous or you are getting fresh water, and before that you are having dense and fractured also limestone. So, that kind of thing, and in that part the diameter of well is increasing. So, that means there is some cavity or something which has been found in the and that is also recorded in this litholog also. So, the concept why it is same about the resistivity, and some other logs are also given here. So, which we will discuss one by one. So, the resistivity log, or in maybe in the next discussion, the resistivity log records as one or more electrodes traverse the borehole, depending on what we are going for, single electrode or multiple electrode as for the ground like we have done. So, formation resistivity is influenced by the salinity, temperature of the water in the formation pores and drilling mud, because here while drilling the drilling mud has also gone. So, that has to be also kept in mind whenever we are getting all these logs, that drilling mud will also influence our signals to some extent. Some types of litholog or some types of logs would be more influenced by the drilling mud, some may not be. So, in resistivity logging, in case of a granular aquifer, the following relation holds good, that is RT equal to RW upon theta m, F, and this F is the formation of resistivity, RT is the formation of again resistivity. So, here in F 1 upon theta m and RT again, which is F, and we can write like this F RW. So, that kind of relationship in case of granular aquifer can be defined there. Further, in case of if a cementing has done, sometimes cementing is required during even drilling time or gravel packing, other things, because there might be some cavity or fractured, highly fractured zones where a well may collapse. So, if cementing factor also varies with different rocks between non-cemented sand, and that cementing factor may vary between 1.3 to 1.6, and in case of sandstone and porous dolomites between 1.7 to 2, and then in a dense formation 2.2 to 2.6, because relatively to the water the resistance of the rock fabric is very high. Rock fabric means the rock made from those minerals, and of course, the cement which is holding these minerals or grains of the rock. So, that is what is the rock fabric is. The formation factor is always greater than unity. So, these values would be always more than 1. So, formation factor is also related to the resistivity of the drilling mud. As I was saying, drilling mud resistivity is equally important. So, is also related to resistivity of the drilling mud Rm and the mud invaded zone, that is Ri, and this relationship is F equal to Ri upon Rm. So, this will give you again the factor. Now, as in case of surface geophysical methods, similarly in case of geophysical well logging of resistivity logging, different electrode spacing and configuration are used. And what are two different configurations we have discussed in surface geophysical methods? One is Banner, another one is Schlumberger. So, similarly here different electrode spacing and configurations are used to obtain resistivity logs, but a single point device or single electrode is adequate to define bed boundaries or contact between different formation and to distinguish porous from relatively less porous formations and formations containing saline and fresh waters. So, if we see a resistivity log here like here along with the litholog which is shown here, then what we find that the resistivity in case of we have encountered now water table here. So, resistivity is showing a completely different signatures as soon as we encounter the water. Then as clay formation comes, it goes down and then again come up, and likewise it is doing like this. So, the resistivity log is a quite good matching, showing a very good match with the litholog. But someone can argue that if everything in all these logs are having good match with the litholog, then what is the use of these things? No, because what you are recording through during the drilling and whatever the rock pieces which are coming, that is not a basically a complete record. If you recall the previous discussion in which we said that every 5 minutes or every 10 minutes or every depth, 1 meter depth one sample is collected or 5 meter depth one sample is collected. So, in between there might be some changes in lithology. So, therefore, it is always good to have a litholog which is whatever the sampling techniques which we have adopted during drilling along with all these geophysical well logs, which will give you a complete idea about the bore well, a particular bore well and its characteristics also. So, resistivity, in case of resistivity logging, this quantitative estimation of formation characteristics and salinity of interstitial water multi-electrode logging methods are employed. And multi-electrode, as I have said, two possibilities are there, and then various corrections for hole diameter, because diameter, as we have seen in the previous lithologs or logs, that the diameter is also changing depending on the lithology or formations. Mud resistivity, some places there will be more mud, there will be less mud depending, and mud penetrations of aquifer, how much mud has gone inside the aquifer, bed thickness, thickness of different formations which are encountered in a well, temperature of water, and other are required for interpreting measured resistivity in terms of resistivity of formations of water. So, water rich formations, without water rich formations, how the resistivity varying, that will give you lot of information including your water table information. So, resistivity measurements are used for of course, lithology to compare and confirm that whatever it is showing is also almost same in case of lithologs. Also correlation and source rock identification, and then over pressure identification, also the porosity of the rocks which are present or formations of the porosity, and finally formation, water salinity and hydrocarbon saturations. So, this hydrocarbon saturation, this is a typical example from oil industry. Also the source rock is also an example of oil industries, but other things are related with water. So, this because the methods are common, that is why these terminologies are also appearing here. So, with this I end this discussion. Thank you very much.